In this video tutorial, we're going to discuss how to create dummy walls for load transfer of one-way slabs onto a podium slab in Adapt Builder. In this tutorial, we're going to be using Builder 2019. We're going to have Edge and Floor Pro enabled, and then we would also want to have PTRC enabled in order to develop post-tensioning on the podium. So we're going to go ahead first and we're going to use the modeling option to set up our stories. We have a current plane, top plane, and a bottom plane. Those are the default planes. I'm just going to relabel these. We're going to call the current plane the podium. So there will be a podium down to the base. I'll apply that, and then I'm going to just call these others plane 2 and so on. So we'll go ahead and add a few more planes here. These will be essentially the planes where we reference the different bearing walls for the system. Let me go ahead and change those so we have the right plane structure. Okay, all of our levels are 10 feet. We're working on the podium level, and I'm just going to go ahead and set up a generic model here using the floor wizard. We're going to do a 3-span by 5-span model. We'll say the spans here are 34 feet, the span in this direction is 32 feet, the slab I'll say is 12, and then we have some columns, some loading. This will actually add post-tensioning for us. We'll just assume that this is our podium, and in this podium we want to go ahead and model in some wall stacks. So we're going to assume that we have, let's say, wall stacks at these locations. They're basically bearing midway between the two column lines, and these extend up to those additional planes that I had created. We'll say that this is essentially the footprint of the timber structure above. So it's a simplified approach, but it should show how we can model these in the program. So what I'm going to do is I'll go ahead and just go up one level. I'll actually go to multi-story and then navigate to my plane 2 as my active plane. So anything I model is plane 2, it's going from plane 2 down to the podium. And I'm doing this so I can reference the podium in the background while I build the different walls that are going to be simulating, let's say, light gauge metal or a wood bearing wall. To simulate those walls, what we're going to do is actually create just an out-of-the-box concrete wall. So I'll go to the model, add structural components, we'll select wall, and here we can set the thickness. I'm going to use a 6-inch wall, for example. And then we could assign a material that gives an equivalent self-weight to the wood bearing or light gauge steel wall in the concrete material assignments. I'll just go ahead and use a 6-inch wall, and I'm going to place that along some path that might represent the building or timber structure or light gauge structure above. Now you could import a CAD file that references where the actual walls are. I could use the DWG or DXF import option to get that into the model to show exactly where those walls are. Here we're just kind of arbitrarily selecting walls and then setting them. So I'm actually going to copy this wall down, and we'll put one essentially mid-bay like so. Those are the walls. If we wanted to assign a different material to those walls, I could go to Criteria, Concrete. I would add a new material. I could then adjust this W sub C for the weight of the wall to make an equivalent timber or light gauge steel wall. So you can adjust any material here. If we're not really accounting for these walls in terms of a global model, we're just modeling them to get load transfer through them down to the podium level. So if we wanted to run the entire structure for simulation of a mixed concrete and other material global structure, that would be harder to do because then we have to simulate the stiffness of those components and the different conditions of the components in terms of their fixity to slabs and to the podium. So this is primarily only for load transfer down to the podium. So we'll go ahead and just say, okay, I'm going to assign those to concrete 2 even though I really didn't change that. I'll go to, once I select those, I'll go to modify the selection. And we're going to go to material, and I'll just switch those over to concrete 2, or you could do one by one modify under this dialog here. Once I have the wall placements there, I'm going to navigate to the level or I'm going to switch to single level. If I switch to single level, now all we're seeing is that level, and we can see in 3D view those are the walls that are representing the bearing walls. I'll now add a slab. Now, just by the layout of the walls, the slab is primarily going to act one way. We could force it to act one way by using stiffness modifiers, but inherent to the way that the supports are placed here, this is going to act really as a pure one-way slab. I'll just model the slab region. Again, if we had a reference file, a DWG, this would be more exact. This is just adding something onto the structure. Similar to walls, I have two options here. I can equate this thickness of the slab using the defined self-weight of this property, concrete 1. This equivalent thickness might be 2 or 3 inches. If it goes too low, there's an initialization value for slab thickness. So in other words, I couldn't enter a slab that's 0.5 inches thick. I would have to change that INI value. So again, you can either manipulate thickness or you can manipulate the concrete assignment to get you to the correct self-weight of this structure, or you could zero out the concrete assignment and then just apply load external to this slab as a patch load. That's actually what I'm going to do here. I'm going to come back to the material assignment for concrete. I'm just going to zero this out. I'll define this as concrete 3, so it doesn't really matter what my thickness is, and then I'm going to apply that load as a self-weight type load. So we're going to go over to loading, load cases. I'm going to add a new load case. This is going to be called LG self-weight. Okay, and then I can select this slab and add a load to that slab, assigning it to this value. And we're going to just assume that that slab is 75 pounds per square foot. For the self-weight, I could also add dead and live load. So if I have dead load, maybe the dead load's 25 pounds per square foot, and the live load for this structure, this is really a timber or light gauge metal level, maybe that's 40 PSF. Okay, so once that's done, I can just take these. I've selected the slab, the walls, the loads. I'm going to vertically copy those up 2 more times. So we'll go to modify, vertical copy. We're going to copy this up. I think it's 2 or 3, I'll say 3 times. It will actually only fill in the number of levels that we've assigned. So now I have loading simulated slabs and walls that are stacking down to this podium. I'll go back to global. There's my podium. Those are the simulated levels for timber or light gauge. And what I want to do now is go to loading, load takedown. And in this tributary loads dialog menu, we're going to generate the tributaries and we're going to recalculate loads. Now what this is going to do is it's going to store the load takedown reactions in the walls and allow those to be used when we go back and we analyze the podium level. So I'll go ahead and just delete it, select OK. Let's go ahead and turn off the loads, and if I go over to the result browser over here, this is the result display settings dialog menu, formerly called, I can turn on the load tributaries. If we go back to single level mode, we can see the tributaries that are being created. That's these red lines define those tributary regions, and I could look at cumulative loads, cumulative areas, and so on for those regions. And these loads roughly on the interior should be identical or close to it based on their tributary. And I didn't place them super accurate, so there's a little bit of a difference. And then the loads on the exterior should be roughly the same. So once that's in place, let me go back to multi-level mode. I'll turn off these options here, and we're going to go to single level. And I'll go over to the podium. I'll just jump down to the podium. Now, at the podium level, if I was to mesh this level, I'll go ahead and mesh that. And I'm going to go to loading combinations. And I'm actually going to just test this. I'm going to add a combination where I just use 1 times, let's use 1 times LG self-weight. That was the load that we applied to simulate the load, the self-weight of the floor on those levels above the podium. And we're going to analyze this level in isolation in single level mode. I'll execute, and I'm going to set this one combination, 1 times LGSW, include the load takedown, and you can see there's a reaction set for that load. It's based on tributary, not on finite elements. And if I go ahead and I apply that and run that on single level mode, the program uses those reactions that were stored from the load takedown. And we can take a look, for example, now at the, let's go here and look at the slab deformation just to see what that looks like at these locations. So you can see some hot spots there where we have deformed kind of max deformation for that particular load. I can always go over to render model, and under the render model we get those hot spots shown, get some warping there. I can look at more of a realistic view of what that actually looks like under this view. You might have to warp that. So this might be a better warping tool here, but you can clearly see the bearing wall stack and the loads that are coming down on those locations from the load takedown. If you have any questions about this process, please contact us at adaptsupport@risa.com. Thank you.